All right, first of all, good job. Well done with your talk. Tough act to follow. I'll try. Am I audible? Is this mic working?
You are loud and clear.
Okay. This thing is working, right? Okay.
That's for the remote. That's for the remote. But yeah.
Yeah, there's this other one.
Yeah.
Yeah. Okay. I'm audible. Okay, cool. All right. So I was here last month as well. I was talking about Agent Gateway, another very popular open source project. But just to reintroduce myself, my name is Akshay, and I've been working at Solo for close to 4 years now. I am their APAC lead for customer success. So everything that the sales team has promised and thrown over the wall comes to me. But yeah, so I've been working with one of the largest banks here in Australia for a long time. I support them almost on a daily basis. Starts with the M, go figure. But yeah, I've been working in the STO space for close to 6 years now. Before that, I was at Red Hat, and I was an instructor at Red Hat. So I used to teach people Kubernetes, Red Hat Enterprise Linux, Ansible, all those cool stuff. And yeah, before that, was working in Combank and multiple other places. So what we're going to do today is we're going to start small. We're going to talk about agents and Kubernetes. I think you did a wonderful job of introducing some of them, but I'm just going to reintroduce it, and just to get a bit of interaction going, just to see the pulse of the audience as well. Just want to make sure, how many of you know Kubernetes and run it on a daily basis? Okay, so we see half of them. All right, what about agents? How many of you develop agents, deploy agents? Pretty much the same half, okay. All right, cool. So I'll try and cater to both the audiences, obviously people who are just starting out, as well as maybe some of the more advanced folks who have been using it for a long time. Quick, for those of you who've been using Kubernetes, what is Kubernetes? Like very simply, in simple terms. Anyone? Yes, it's an orchestration engine for containers. Very simple, right? That's what it does. And it has been around for a while now. But for those of you who've never used, I think probably half of the room who's never heard of or used Kubernetes, think of it like a basic thermostat for your software. Where in a thermostat you say, I want the temperature to be, it's very cold outside, so let's say 20 degrees Celsius. And you set and you forget. And you let the thermostat do the rest for you, that it will adjust. So that's what Kubernetes kind of does. It will go and you declare your intentions that this is what I want, and it will go and set that for you. In more technical words, it's a orchestrator for deploying or orchestrator for managing your containers. Now, what is an agent? For those of you who work with agents, what does it do?
Hopefully makes life easier.
Hopefully makes life easier. I like that. Sometimes difficult. I like your analogy as well, where you explained agents. I think that's hopefully makes our lives easier, right? One analogy that I personally liked was when you write a script or something like that, right? It follows a script. That it follows a step, like one step, two step, step by step. An agent is more like a cook, right? You give an agent a task and you say, go figure. And hopefully it knows what to do correctly. So just the dinner analogy, like go make dinner for 6. And then you hope that it will go and use the tools in the kitchen and adjust depending on the taste and things like that. And hopefully, it will give you the right output. But sometimes it doesn't, right? As we all know. It will very confidently serve you a burger and say, oh, this is biryani. And it does that. So definitely more formal for those of you practitioners. It's more like it's an LLM as a control logic. It has a reason, act, observe loop. It will call tools over MCP, and so that's your typical practitioner definition. But I think we all sort of, hopefully in the room now, have a kind of understanding about Kubernetes and agents. Now what we're going to do is we're going to marry the two, kind of, and talk about KAgent. So the K is like Kubernetes agent. Now, KAgent was started back in about a year back now. But in a nutshell, what it does is it teaches Kubernetes one new word. And that new word, as you would have probably guessed, is agent, hence KAgent. So those of you who are familiar with Kubernetes, right, half of you, kubectl get pods, you'll get something. Kubectl get services, kubectl get deployments. That's your bread and butter, right? You do that every day. But if you want to do kubectl get agents, this is where KAgent comes into picture. So basically, it introduces the word agent to Kubernetes. It's a runtime for Kubernetes, for running agents. So how did it all start? This is probably a very, I don't know, I've been working in, I was in the US as well. I was helping a lot of big financial institutions, and I was an on-call engineer. And I'm still an on-call engineer here at Solar as well. And typically you'll get a call at 3 o'clock in the night. Incidentally, I was on call last week as well. So, and then people call, and then you'll be waking up in your groggy voice and trying to say, hey, what's happening? And then something is obviously down. And then you go and log in your laptop and see what is happening. And maybe in your half sleepy state, you're trying to figure out what it is. Maybe there's a pod which is crash loop backing, right? And then you will check the pods, you will describe it, you will see what's happening, you will check the logs, and then you will try and see what the error is. And maybe there's some issue somewhere, there's some config map that has an incorrect typo or whatever. So clearly, I mean, that is something that has happened with a lot of us who deal with that. But a lot of that is something which can be offloaded to agents who can do a much better job. They are very analytical. And if that thing is happening, that incident is happening in the cluster, it actually makes sense to have an agent running in the cluster itself to figure those things out. That's how actually KAgent started off. We were, as you probably have known, Solo, we work extensively in the STO and an agent gateway and the gateway spaces. And invariably, we'll get calls saying, hey, something is not working. Something is down. And we would get on calls and try and figure out what is happening. And a lot of times, the answer is actually already there in your cluster. So what our CEO, Edith and Keith, who is our Chief Product Officer, they started this as like a fun side project of, what if we create something which gives the agent the runtime of running or diagnosing things which are happening in the cluster. So in 2025, this is when we've announced KAgent, 17 March 2025, just for the history buffs. And then obviously it took its own it's been more than one year, 4-5 months now. And 18 months in, It has about 3,400 GitHub stars, a little bit more than OpenCorea, but who's counting? I'm just kidding. Yeah, these things have a way of, especially when it comes to CNCF projects, like it has a way of, when you open source something, they have their own way of taking shape and form. Community decides how to shape the project, what it's supposed to do, and things like that. So Solo.io, started it, but if you see the stats, there are about more than 85% contributors who are not even at Solo, and people who are using it. I was at KubeCon Japan a couple of weeks back, and I was talking to Amit as well. And I was surprised that people are actually running KAgent in production. So this is open source project where people are actually using it in production. And I was pleasantly surprised, like, okay, this is very cool. They're like, oh, we actually use KAgent in production. And I was like, okay, that's very cool. What do you use for? And what are the use cases and things like that? And that's when I sort of realized that, this is actually really cool. What is more interesting is people are actually filing bug reports saying, hey, fix this, fix that, which actually means the community is actually very alive and doing real things there. So one question obviously is, you can always spin up an agent of sorts, right? You can connect it to an MCP server. I can do it on my own laptop, connect it, and it works. I can connect to a cluster, make it work, right? But I think the bigger problem is, what if you want to ship it? Not something which runs locally on your laptop, but if you want to have it shared by a team or at an enterprise level. What credentials do you want to use? Definitely you can't use your own credentials. And who's allowed to change and do what? In RBAC sort of thing. How do you stop it when it misbehaves? Now, all of these are platform questions. These are not really AI questions, but these are more platform and governance sort of questions. So thing is, we already have an answer. We already have Kubernetes who does this all of these things for you. So the whole logical step was to use the Kubernetes runtime or to use the Kubernetes objects and have your agents run as any other Kubernetes object. So that's exactly what KAgent does. It creates or makes your agent just like any other Kubernetes objects. And once that happens and you get a YAML file, it's boring. Like, it's basically YAML files and it's all declarative. But that's the part that you don't have to worry about, because now Kubernetes can take care of what it does best, right? It can, how you've already solved things of deploying things in Kubernetes using Git as an example, right? You can you can version them, you can deploy Git. So basically, you can use Argo or Flux or whatever GitOps tools you have. How do you control it? Again, RBAC, that's how you can do kubectl, and you can have service accounts associated. So again, you don't need a new platform. You don't need a new console for that. Kubernetes already does that for you. So what we did is we just create a runtime for you to have your agents run in Kubernetes. Wow.
Very romantic.
It was very romantic. I'm going to skip over this part. I think we probably all know in an agent we have your model. And again, when you are doing this with Kubernetes, with KAgent, doesn't matter what model you're using. It's really up to you. You can use OpenAI, Anthropic, Gemini, blah, blah, blah. There's so many options. Then prompt, I think that's an interesting part. This is where you should make sure that you write a good prompt. And tools, wherein something that you call through your MCP, basically like a USB for your AI, standard way to plug in your capability. And that's basically the anatomy of any agent. And you can use KAgent to define those. Again, what model you choose, what prompt you write, what tools you write is something up to you. The boring part where we have to orchestrate the thing with Kubernetes is taken care of by KAgent, right? So you worry about things that really matter, which is what should go in that prompt, because that's really important, right? You need to know exactly what that agent should do, what model it should use, again, depending on the cost and things like that. That's an important decision that you guys need to do. And then what tools it should have access to and not have access to. I think that's also a very important decision. If you have 100 tools, what we've seen is if you give access to all 100, the quality of output reduces drastically. You would rather give them a small subset of tools, let's say 15 to 20 tools, and it would perform better rather than having like 100 tools given. Yes?
So I have a question. So if I'm not mistaken, Christian has said that, Christian Costa,
yeah.
he said that MCPs are not the best way to talk to your respective other tooling, and potentially you should use or leverage API. Is that still the case after MCP 2.0, or what's the goal there? And would you all use the same sort of tooling within your KAgent because of that, or do you all recommend something else?
I have no idea of what Christian said, but I can check that with you, with him. In terms of KAgent, again, it's pretty open. You can use any protocol that you prefer.
Yeah, but is that recommended from KAgent side, or is that not the recommendation of the way to impact the external tooling?
No specific recommendation that I know of, but I can check. I'm not 100% on that. Does anyone else know the answer? I have no idea. But I can check with Christian and let you know. There's so many things that keep on coming. It's very difficult to keep track of this. It's ridiculous. I'm sure if something else new comes up, this talk will be old in another week or so. There's just so many things that keep on. Yeah, we have no idea. Like, and that's what some of the things that I've learned like a week ago that I'm going to talk about today. So which is very interesting. Just the sheer speed of how things are changing, it's crazy. But again, the basics remains the same. You have your agent spec, you have your controller, you have your runtime pods. Again, and for those of you who find YAML boring, CLI is boring, there is if you are using KAgent, there's a UI as well to drag and drop things. Again, I don't mind CLIs, but the UIs are sometimes a bit more easier. So what I'm going to do is I'm going to do a brave effort and see if this actually works, and maybe hopefully just show you guys a sneak peek of how it all looks like. Hopefully the demo gods are kind to me. Let's see. All right, and this is running on my local kind cluster. I've just set it up. So let's go ahead and all right, cool. So far, so good. What I've done is basically I've installed KAgent. Again, this is all open source. I'm talking about specifically only about OSS. This is something that you can install in your laptop right now. All you need is Docker. That's it. You know, and maybe Kind. I'm using Docker and Kind as well. So I'm just going to walk you through a basic demo of how the UI looks like and how to get started. So maybe let's just get started. So let's get started. Again, configure an AI model. For me, I was just using the cheapest model, just the Open API GPT 4.1 mini. But again, this is something that you guys can, really decide what models should be available and things like that. And then I'm just calling it the demo one, which is called as the My First Kubernetes agent. We're going to create it in the KAgent namespace. You can give a description, and this is really critical. The system prompt, right? This is where you actually give the instructions to the agent. In this case, it says you are a friendly and helpful agent that uses Kubernetes tools to answer questions about your cluster. Always be helpful, friendly. If you don't know anything, say sorry, I don't know. All the basic stuff, and then you can select the tools. Again, Argo, Cilium. These are just some ones that come out of the box. You can always create your own MCP one. There's a KMCP project as well. You can publish it and use this. Again, just a sample one for now. Just click the basic ones, and then you can create. And this is what happens with live demos. Oops. Just go and see what happens. Nope. Let me go on. First of all, drag this. I swear this was working.
Did you create the demo box?
I did. Let me give this one more try. Sorry?
If you scroll up, you left yourself a message saying if the agent's already there, it will collide.
Oh, okay. Maybe it's already there. Maybe I'll just reset this.
Good catch.
Always fun to troubleshoot things in a live demo. Yeah. I have no idea what's happening. Let's just give this one more try. Pretty sure I did reset everything. No. Just give me 1 second. Yeah.
Yeah, so basically, Christian, who is one of the maintainers of this, has basically said that MCPs are not necessarily the best way to interact with your APIs. Better than that, you are better off actually interacting with the APIs themselves. Yeah. So actually doing deterministic calls rather than hoping the MCP calls are right. Yeah. Which is why this whole question came about. And I think there's, at least as far as the applications I've written, I've started doing that. So even, for example, when pulling, debugging an issue, you don't want to pull all the logs confuses, or you get worse output and worse results or worse recommendations. Versus if you pull just
Oh,
50
it
lines
works.
or 50 lines. I've started getting better results for it, so the script just works.
All right, lo and behold, it works. Yay, I have no idea. So what has happened was, while I was there, I was actually rerunning the steps, and then this agent was already there. So that's the reason it was erroring out, because my first agent is already there. So I just deleted it and it worked. All right, cool. All right, so this is your first KAgent, and again, you can chat with it and sort of figure out if you want to say, hey, just say hi, talk to me, or whatever. And then this is how you can sort of create your agent. Hello, hi, I'm your Kubernetes agent. I can answer questions related to resources, pods, deployments, services. How can I assist you today? So again, you can just play with these with this agent. You can ask questions like, can I know the status of my pods? So it will go and then it will say, okay, here is the status of your pods. Most pods are in running state. There's one shop namespace which is having issues. It's in crash loopback and things like that. So basically, it just gives you what's happening with your current Kubernetes clusters. I'm so happy that was working. Now, what I'm going to do is I'm just going to go back to the CLI. And just give me 1 second while I move this to the left and to the bottom. Okay, perfect. Let's go ahead and clear this. In the background, this is what is happening, right? So we created this my first agent, right? So essentially, it is just a bunch of YAMLs which is running. So if you were to see this output, it's basically something that you already know, right? For those of you who work in Kubernetes, it's a standard CRD, this is your agent. This is the model that you've selected, your message, the tools, and you can do a selection of tools. In our case, we did the get me all the available API resources, tell me about the Kubernetes API, and things like that. So you can basically go on and build on this. But at the end of the day, this agent is running as a pod, right? So if I just do a kubectl get pods, there should be there you go, right? My first Kubernetes agent, that agent is running as a pod. And what will happen if I delete this? Whole demo will crash and burn. No. Kubernetes will do its thing, right? It will see that, okay, I'm always supposed to have one replica or one pod running, and then it will see it and go ahead and recreate it. Demo gods? Let's see if this happens. Kubectl delete pod. What's the name of the pod? This guy. Let's give it the namespace. All right, it's deleted it. But hopefully, if everything works correctly, it should have spun up another one. Ah. Where are you? Where are you? Ah, yay! 15 seconds ago. Cool. So that's basically the power of Kubernetes, right? Wherein you don't have to worry about your agents. Kubernetes will take care of. If you tell it, this is what my end state is, and Kubernetes is going to take care of you, right? So that's because we are deploying our applications any which ways in Kubernetes, so might as well make sense to run agents the same way. Now, what I'm also going to do is I'm going to borrow your example, because I was just trying to do this really quickly while I was there. And I thought, why not create the same SRE example that you did? I thought, let's just create an SRE buddy as well. So there is one which is already out there. And maybe I can show it to the UI. It looks a little bit prettier with the UI. If I can figure out where my mouse pointer, okay, there you go. All right. Let's go to home. So there is one SRE buddy. And what this does is it sort of goes and checks what is happening and fixes it in the environment. So I'm just going to say check all the pods and tell me the status. And I have no idea what this response. It gives me different responses every single time. So we'll just try and see what response it gives me. Okay. Here's the status of all pods. Most pods are running. There's one pod in the namespace shop, which is crash loop mapping, restarts multiple times. The broken pods, should I continue investigating the cause of this crash? Okay. Yes, please. And it will go and check what's the problem. There's a database URI key, some typo there. Currently, there's some misnomer causing to be applied. Okay, fix it. Okay, please, 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 please fix. All right, cool. So this is what I wanted to show. The list of the commands that we had given access to, like we had given Kubernetes read access, list access. The thing that scares me, and I'm sure it scares all of the engineers who are on call, is giving write access, right? Going in and changing. And agents are great, right? But they can be wrong, and you don't want them giving them access, especially in production-like environments, to write access and start deleting stuff. And this is the concept of we call as human in the loop. This is why we all exist. And what we had done was in the agent that we had created, and again, it's very easy to do. You can do it in the same way that I created the first agent. Again, you can do a YAML file. And it will go ahead and ask you, should I actually do this? Should I actually go ahead and change this? And if you think that this is a reasonable thing to do, you can either approve or reject. I'm going to say approve. And obviously, it would want to roll out, restart the deployment. I'm going to say that is approved as well. All right, cool. Let me know if you want to check the state. Actually, I'm going to go to the terminal and actually see if it actually has done that. Let's just say kubectl get pods all. All right, there you go, right? So these 17 seconds pause that you were seeing, actually went and fixed it. It was actually crash loop backing, right? So a very simple example. So this is what it can do. Again, you can always build your own stuff, build your own agents. Depending on what your need is, you can obviously make sure that you write your own agents, you write your own prompts and things like that. Now, this is what most people are using KAgent for in production for, where they are deploying their own agents. They are deploying agents in Kubernetes. They're sort of orchestrating or using KAgent as a runtime to do that. And in most cases, if it's an SRE team, they might be doing something like this. But there are other developers who actually use it to run actual agents in Kubernetes. So this is how most people that I've spoken to are using KAgent open source in production. But again, as you probably know, things keep on changing in the AI world so often. I also wanted to give you a sneak peek of what's going to come, what's happening currently with the KAgent project, and what's going to happen in the next few months. But I think this is a good logical breakpoint if there are any questions that I can answer.
Can you take the human out of the loop?
You can, yes. At your own risk.
Yes. I mean, on specific agents that you create.
Yeah. Yeah. Yeah.
Is there a way to trigger them without actually talking to them?
Yeah. At the end of the day, it's a YAML file. So you give instructions in that. And then you can, like this one, like specifically, maybe I'll just show it to you. Kubectl get agents. So there are a lot of them who actually don't require any approval. But this one, I'm just going to show this to you. Is it agent? KAgent agents. All right, cool. So you see these various options. You can actually pick and choose over here what are the rules and how do you want it to work. So it's really up to you on how you want to basically structure it.
So in the instructions you said always keep a human in the loop.
Yeah.
Okay.
So there should be a stuff wherein we actually have specified that for certain operations, like write operations, you'll need to basically get permission. So.
Oh, I see. The required approval.
Yeah. So again, really up to you how you want to slice and dice them.
I have a question on storage. So you have a list of agents sprung out, right? Are they all sharing the same storage layer to store the memories, conversations, or each agent you can assign a database for each agent, to separate the storage?
It's just a pod at the end of the day. So whatever you could do with a pod, you could do with it.
Is it because then with the system prompts, is there a pattern you would suggest to enforce like global or like a composable system messages? For example, I want every single agent to be able to have this part of the prompt as part of the system message. Is there a way to do it?
Oh, templating?
Yeah.
Shared skills between them.
You could, yeah. You could
without them being injected in the prompt, you could say, get, yeah, okay.
Can you mount, can you use config that for the system prompt?
You could, yeah.
Oh, nice.
Yeah.
Because it's,
Yeah, and then you can mount environmental.
Yeah. Like whatever you couldn't do for a typical pod, right? You can do it.
I noticed it had type declarative.
Yeah.
Are there other types of agent?
Let me check that for you.
Because we've got a lot of people looking at Bedrock agent call
Right.
as an example with the strings, SDK, all that stuff. So people want to bring their code.
I can check that. Yeah, so there are two types, declarative and bring your own. So in bring your own, you can use an agent which is written in LangGraph or Crew AI or Google AI or whatever it is. You can bring your own as well.
Okay.
So two more important types.
That was my question. Bring your own.
Yeah, bring your agent, yeah.
Thank you.
Any other question? Yes, sorry. Ladies first.
So in SRI agent, SRI has the human interaction, right?
Yeah.
So what if the person is unethical? Like if it can be, how secure is the system?
Okay, so the question is, what if the person who approves
Who approves
is unethical?
Yeah.
Okay. Well, interesting question.
I guess what's RBAC?
That's
Who has control?
so yeah. So thing is, think about it in the same way that you would for any other of your current applications, right? What if someone has access to just delete the entire thing? In that case, you have systems in place wherein you would need higher approvals, for example. You can have checks and balances in place wherein you won't allow one person to approve or disapprove. But it's a more ethical and not.
Authentication in it, like only authorized person.
Yes. That's a good question. So it has identity. So the same way you have role-based access control. So for example, you can decide, for example, I'm a cluster operator. And it's very, very common use case, right? For example, separations of concerns, right? For example, a cluster operator will typically have delete access or write access, but someone else might not have it. Right? So the same role-based access control that you would typically have for your Kubernetes clusters, the same ones apply for this as well.
So one of the things that is possible is you have to create an agent exactly how you treat a human being. Assume that worst case scenario, someone is half sleepy, half groggy, clicking on things which could be dangerous, and potentially keep another layer of approval if you want. So you would follow the same RBAC which you mentioned.
So I think so that's not like only just depend on a one person.
No, it's the same way how agents you wouldn't depend on one agent. You ideally, like even if you're DevOps and you technically have admin access, you should generally not be accessing via admin. You should have to return the role as well.
Yeah, that's
So,
right. So if I go through all the other roles as well, like you can check that what is happening, who's doing what.
that would be the ideal goal.
Yeah.
If you choose to give it admin access, then that's a gamble that you take.
Yeah, basically the same access control that you would have for Kubernetes, the same ones would apply. Right. Anyone else wants to answer or ask questions? Sorry.
Yeah, just a question. So are you guys also supplying like some sort of a gateway to talk to this agent as well?
Yes.
Or are you leaving that someone else's foot shotgun to use?
Oh yeah. We
The whole night for that question.
How do I hook it up to Slack?
Yeah. So I think, we have agent gateway for the egress use cases, which again is very very important, right? Because who you're talking to, the egress use case becomes even more important. But yeah, from a gateway perspective, it has integration with agent gateway, but you can use any other gateway as well if needed. But yeah, we have some, like, obviously because agent gateway is also Solo's product, so we use a little bit of first class or easier way of handling it. Again, doesn't have to be, but you can use any. So the idea would be that put agent gateway or any gateway in front of every prompt, leaving your cluster. Is, if you have authentication, rate limiting, everything is logged. Again, same sort of audit paper trail that you would typically have. Yes.
Quick question. So you give the example of SRE agent.
Yeah.
That you say a lot of teams using that into their production environment. So just want to know in that scenario, what's the advantage that KGateway can provide it compared to I just install a MCP in this class in my Kubernetes cluster and then just expose that to a local agent to run SRE demos.
You mean KAgent?
Yeah. Yeah, I think so the question is, what if just use a local MCP server rather than using KAgent, all right? Again, it's the same thing wherein you want to, you can do that, but you still have to account for things like role-based access control. You still have to account for where do you deploy it, who is responsible for it. So with KAgent, you just get the same primitives that you get for your other applications for your agent as well. So all the Kubernetes primitives, you'll get it for that. Nothing stops you from just or even my own laptop, you can connect to it, does the same thing. But again, who has access to it? What if it goes down? Those sort of questions are, you don't have to worry about them.
So KAgent has its own identity, right? So it has its own identity. So it's the one that's updating the config and is auditable.
Correct.
As opposed to if you have the MCP on your end talking to it, everything it does is as you.
Correct. Yes. That's correct.
Which is actually a downside, really. Like, if you want to open this up as like a shared platform tool, and anyone can talk to it, the agent's acting on behalf of anyone, right? Like, you would ideally want to pass through whoever's using the agent, pass through their identity.
Yes. So passing agent identity is you can do that securely as well. I can actually tell you about that.
Awesome. Because I was thinking that there would have been that traceability. I talked to it and asked the agent to do it on my behalf, as opposed to the logs appearing like I.
So on behalf of I can look that up. But that is it does have an agent identity component and on behalf of component as well.
So is that a solo product, the agent ID?
No, I mean just any agent identity that you want to use. It integrates with whatever you guys would currently be using. We have support, I think, for a lot of IDPs which are out there.
So the KAgent would use OAuth, for example?
Yeah.
And then, so you wouldn't have any identity authorization configured. It would be an identity platform?
On behalf of.
Earlier you mentioned agent sandboxing. Does that integrate with KAgent as well? Like, can you sandbox
Yes. Perfect segue for the next topic. Okay. That's a good question. So, like I said, currently, when I spoke to folks on the ground, their main production use case with KAgent is using how I kind of showed you. But where the community is going towards is sandboxing. And have you guys heard of Agent Substrate? Who here is? Like, obviously, you have heard about it. But that's exactly where KAgent is going. So the next few minutes, I just wanted to spend on what's changing or what's the future of KAgent. And it's exactly what you've spoke about, right? Agent sandboxing, agent substrate. So let me just go back to my slide. It is agent substrate. So agent substrate is a project which is open sourced by Google. So they have come up with this concept called as agent substrate. And an agent substrate basically gives you a substrate basically means if you are gardening, it's a layer that you grow on top of things, right? In simple gardening terms. Agent substrate is basically the same concept wherein you use that as sort of a layer to have your agents running. It's a very, very new stuff which has been launched by Google only a few months back. And in KubeCon North America, the Salt Lake City one, which is typically happens I think in November. So Google are going to make a big announcement about it. And we were actually at Solo. We were working on something similar of agent sandboxing and sort of doing that. So agent substrate kind of solves the same problem. So we reached out to Google and we are kind of doing the same thing. So it's a very, very new project. It's like 0.0 something. So it's that new. But that's something that again founded by Google. They've open sourced it. You're going to hear this a lot in the next few months, I assure you, because that's again a separate open source project. Maybe we should have Amit a talk separately on agent substrate one of those days as well.
I'll try and get someone from Google who is within Australia ideally to
Yeah, that will be.
come and join hands with Solo to have a joint conversation about it ideally.
Yeah, that'll be really cool because what's going to happen is it's already happened. So what we're going to do is we're going to move the KAgent runtime over to agent substrate. And again, we are not moving away from Kubernetes. Kubernetes still remains the same, but just the way you sort of interact with this agent is changing. So what's going to happen is substrate, which is actually built on top of Kubernetes. So we're not replacing Kubernetes. So you're not leaving Kubernetes. Just that the way it currently interacts is going to change. And I'll maybe give you a bit of context or a bit of a history so that it will make a bit more sense as to what is happening. Again, this is a very, very new space, very evolving. So I might not have all the answers, but you're going to hear about it quite often, and then maybe you can do your own research and things like that. So basically, the idea is that again, agents can go rogue, right? They can talk to other things and all of that. And right now you are running it as a container, basically, which is okay, but we all know it can escape containers. So basically what you do is you have it run in a sandbox, right? And when it launched, it actually uses the gvisor sandbox. So if you guys have been using sandboxes, gvisor sandbox is what it uses under the hood. They're also going to have support. I think they probably already have support for micro VM. So those are the two things that they are doing. But again, the idea is that that's going to provide a bit more. Again, it's going to provide a much stronger isolation, so that it doesn't go and talk to other things. Like by default, it's going to be a deny by default, and without explicit permissions, you can't talk to other stuff. And that's where your agent will go get its own file system. I think you were asking some questions around that. And that file system can be snapshotted. So an agent can then be restarted at a later point. So what it does essentially is, let me try and give an analogy how I understand it. Okay, let's say you are going in a hotel, right? And you go there, and you'll not get a permanent room, right? Where you just get whatever room is available, and then you stay there and you leave, and then you come back and there's a new room. But with agents substrate, it's like you go to a hotel, you keep your luggage, you keep your stuff in a specific way, you go back, and then you come back after a few days, and they give you the exact same state where the room was in, right? Basically, they are going to suspend, in the agent world, what they're going to do is they're going to suspend the agents, and then we're going to call it only when it's needed. Now, the difference over here is like for example, a web server. A web server needs to be on 24/7, right? It's serving traffic every second, every minute. But agent is not like that. It's very it does work in bursts, right? It will do a work, and it will remain idle, right? So you give a prompt, and it does the work, and then a lot of times it's just waiting there, lying idle, for you to give another prompt or do some action. Now the problem with that was, again, resource consumption is one obvious one, but also around security and things like that. So what agent substrate does is, it doesn't boot, it thaws. I think that kind of explains it really well. So a request arrives, and they have sort of a pre-warmed set of pods which are there, and there are some new terms that you might have to learn. So they call it actors. So those agents are actors. The term is called as actors, and those the worker pools are basically pods which are running, and then every actor, again, it in this case is going to be an agent, but it can be anything. When it needs to be get something done, it will go ahead and talk to those pods and do the work. So the agent doesn't boot; it thaws. Basically, it has a snapshot of what it did last, and it will check. Basically, it will be like a file system of sorts. It will have everything that's there. It will check those memory pages. Everything will be stored in an object storage, and then it will just read it from there and give the response. So when it goes idle, it's just going to keep that thing running. When a request comes, it will go ahead and fetch it and serve traffic. So that's the whole concept of this agent substrate. And what we are doing now is we're going to have agent substrate as the runtime for KAgent. So that's the new thing that's been announced. I think maybe a few weeks back, right? Was when it was announced. So very, very, very new. Maybe I can quickly show you a demo as well, if if it all works. But again, right now it's very, very new. The whole idea is you might not have, you don't need your agents to be running as pods. Right now they're running as pods. You don't necessarily need for them to be running as pods. Agent substrate can basically just have a pre-warmed set of pods that are there, and then you can use it whenever an agent is called. You can go ahead and talk. Those pods can then basically serve that information, and then it will go idle again. So again, very, very new, still in its thing, but again, this is the next big thing apparently, which is happening. I can maybe try and show you a quick demo of it, just to sort of give you an idea.
Would you kind of talk about it like serverless agents, kind of?
Yeah, that's a good analogy. Yeah, that's a good analogy.
So does it like keep the file system in context?
Yes,
Yeah.
yes.
And so it just continues on that session from.
Yeah.
Yeah. So think of it connected to a database in the background. So if you had Lambda,
Yeah.
and you just connect to a database. That's cool.
That's a very good analogy. I like that analogy.
These actors change their persona, so to speak, when they're or they're just calling these pods that are just restoring their context.
No, the actors would be different based on your authentication.
Right.
Right. Yeah. Let's see if I can just quickly show you something. These are actually running, but these are just predefined scripts. Let's reset everything first. All right. Cool. Right now, so 11 agents, 11 pods. So it's like a 1-to-1 ratio right now, right? 11 agents, 11 pods. With substrate, what happens is there might be, like for example, over here, there are 73 agents which are currently running, but they are being served by only 6 pods. That's the whole thing. Maybe we'll try and see. Again, this is live in my kind cluster, so. All right, so in this case, if you'll see, how much is this? Yeah, 11 pods, so 11 agents. Yeah, there you go, 11 agents, 11 pods, all right? And obviously everything is using some memory. Then maybe, let's see how, so the thing that's going to change is, remember I showed you that YAML, wherein we defined it as an agent. The kind was agent, right? This is the main difference, that the kind is going to be sandbox agent. So that's the major difference. Everything else kind of remains the same. Now this is going to be a declarative, which is going to run inside the gvisor sandbox. Right, so it will, this one is already there. So again, same pods which were there. So there's a hello substrate sandbox agent which is currently running. There will be 0 new pods which it will add. Even if you add more things, it won't add to chat. Let's go ahead and it won't add to the number of pods that are there. Let's go. Okay, who are you and where are you running? Yeah, so I'm just giving a standard input via shell scripts. So I'm just going to tell it that my lucky number is 42. Make sure that you remember this. And it will have this session ID. This is how it will know that this session ID is the agent instance. And it's going to say, hi, hello Substrate. I'm using the Go ADK declarative agent running inside gvisor. I've also remembered that your lucky number is 42. So if I were to, again, recall this, it will, let's go ahead and suspend this. So all of this is currently being served by only 6 pods. See, these are pre-warmed pods. Again, you can define how many you want, 6, 10. You can also have an HPA scaling event associated with it. But again, the whole thing is that it's suspended and all the file systems are in this object storage over here. I'm going to ask you to resume. Again, I'm going to ask the same question. And if you see, it actually remembers what my lucky number is. It does say that my lucky number is 42. And this is very, very fast. So the whole idea is it will be less than a second, wherein it will go and boots the entire thing. Right, so again, the same thing, wherein right now we have 74 agents just being running using 6 pods. There's also, we can see the same thing in the UI. Let's go and check the UI. So there's pretty sure there's an agent substrate UI.
Is that UI there part of the KAgent UI?
Yeah.
Served out of that main pod?
Yeah. So if you see over here, it will give you information about agent substrate, how many worker pools are there, how many actors are currently running. So this is the thing, right? Currently, there's no agent which is running. So zero of the 74 actors are currently running. It's only when I go and invoke it that it will go. It will go and check anyone from these 6 pods. Will go and fetch that information, and it will give that result.
So is that the actor's only live while it's answering like questions?
Correct.
Like
correct.
So when you the chat asking for like,
Correct.
It existed for
For that time, that's it. Exactly. Which I think is pretty cool because now you don't have to have that agents running or the pods running, just sitting, doing nothing there, right? So that's the whole point of, not only that, but also the security portion of it.
It really feels like Google's agent entered to AWS Bedrock Agent Core, which does the same thing. Like you don't pay for it when it's not running. It's got great isolation. It's like the whole speed. It's the whole, yeah.
Which one is that?
Bedrock Agent Core. AWS has this thing called Bedrock Agent Core. And
Right.
the whole premise that they tell you is that it's shut down and it's not working, and yeah, it has the ability to have memory and all this other stuff like that.
Right. Yeah.
And it's got the greater isolation.
I'm sure Azure is going to come up with something similar,
Yeah.
if not already. But yeah, at least in this case, this is open source. So
Yeah, I would much rather run this.
yeah. So they are going to make the announcement of the CNCF donation at KubeCon. So that's where they'll actually open source it to everyone. I mean, already open source, but they'll make the whole CNCF announcement and things like that.
And Google is also coming up with somewhat similar, or they are going to announce in KubeCon? Is Google also about to come up with somewhat?
Oh, this is Google. Agent Substrate is all Google. It's all Google. We are sort of contributing. So it's funny. They actually reached out to us because we were going to come up with something kind of similar, but then we're solving the same problem. They're like, okay, let's kind of make this open source and work on this together. So that's the reason we were like, okay, let's make this as our runtime in KAgent as well. But yeah, I mean, so many new things happening. It's this field is changing so fast. Like it's so difficult to be on top of things. Like everything which is so new, and it just changes so frequently. I was at KubeCon Japan. Very interesting story. I met Kelsey Hightower, and his thing was always like, it's an implementation detail, right? Doesn't matter what the underlying thing is doing. It's just an implementation detail, and we were talking. Oh no, but this costs a lot of money, right? There's so much tokenomics was the hot topic at KubeCon Japan. I was just talking to Kelsey about it, and he said something really funny that I thought I should share. He said, oh, you know what? There is this zero token architecture thing. It's like really cool. I was like, oh, okay, what is zero token architecture? You just use your own brain. That's my time. Thank you so much.